All right, students. So for today, we're going to go over very quickly our last DCA. We're going to do this so that we can have our retest today because today is exam day. All right, so make sure that you have a matching title for our last DCA, and then we'll go over number 1. The algebraic expression represents a transformation of rectangle A, B, C, D to rectangle A prime, B prime, C prime, D prime. Which statement is true? So I'm going to change these coordinates to these coordinates. And since this is just adding and subtracting, I know that this has to be a translation. So I'm going to go ahead and find all of the answers that have translation. Okay, and I'll cross off the answers that don't work. Now, between the two translation answers, one says it will be congruent, and the other one says it will not be congruent. Translation does not change the size at all, so the answer will be A. It will stay congruent. Okay, for number 2, triangle XYZ is reflected over the y-axis. Which algebraic representation or rule explains the effect of the transformation? First of all, I'm going to draw a coordinate grid, and then I'm just going to pretend that I have the coordinates over here. And this would be my X, Y, Z. Reflection means flip, so I'm going to flip this over here. In the process, I noticed that the same shapes have the same heights vertically. However, they move to the different side of the x-axis. So that means the x's turn negative, but the y's stay the same. Remember, the x's are all positive over here, the x's are all negative over here. So I'm going to go ahead and pick out D as my answer. And I'm picking out letter D because the y's don't turn negative. The y's all stay positive. The y's are positive. All right. Number 3, I have a table that shows me these rules. Determine which algebraic representation or rule shows the relationship between the two shapes. It doesn't matter what shape it is. It could be another four-sided shape because there are 4 corners. It could be a square or a rectangle. It doesn't matter. Okay, over here, I look at my numbers and then I look at my answer choices. I have all these adding and subtracting choices. So I'm just going to pick the one that is correct. So if I want to change from -4 to -7, I'm going to get more negative. So I don't want to add, and I don't want to add there either. So I'm going to cross those off. I notice that my y's also change and they get less. So 2 to 0, 4 to 2. The x's change by -3, so -3, and the y's change by -2. So I'm going to pick letter B as my answer. And you can double check this with your calculator. So if you want to hit pause and you want to check with your calculator, go ahead. That will help you understand why you missed this question if you take a pause and check with your calculator. Okay, for number 4, DeAndre started with a triangle, RST, and then he performed 4 different transformations. After which transformation is the figure not congruent to the original triangle RST? Transformation 1 is a reflection. Well, we went over in our review. Hey, reflection does not change the shape or the size. Number 2, rotation. Rotation is just a turn. If you turn something, it doesn't change the shape or the size. Translation, up 3 and right 1. We know that if we move something, that doesn't change the size or the shape. Okay, dilation is our transformation 4 by a scale factor of 1/2. Okay, that does not make it congruent. If you remember that this dilation, because the scale factor here is less than 1, this would be a reduction. Hey guys, by definition, reduction means the shape will be different, right? Okay, so my answer here has to be letter D. All right, for number 5, I have triangle ABC. These are the corners. That's what vertices mean. These are my corners. What transformation is represented by the following algebra expression? So x and y will turn into minus y comma x. In order to show you which one this would be, I went ahead and I plotted this on a computer program. So please take a look at what happens to my graph on my computer. So here I have A, B, C. I'm going to take A, B, C. Let me go ahead and choose all those corners. Then I'm going to go up here where it says transform, and I am going to rotate. I'm going to rotate 90, so that means I'm going to rotate it 1 time. Let's see what happens. This gives me a new set of coordinates. These coordinates over here were my old coordinates. They have labels. So let's go ahead and label these new coordinates. So these are my new coordinates. You see A prime, B prime, and C prime. And then over here, the computer has nicely organized my coordinates for me. Let's go ahead and just put them in order so I can compare. Okay, now I have these in order. Let's look at A and A prime. Notice how they switched places, the X and the Y. And then this -5 turns into +5. So I switched the order, and then the first one turns opposite. So it goes from -5 to +5. Now let's look at what happened to my shape. My shape went from here to over here. And you notice that this is not just a reflection. I turned it because A prime is not at the left-hand side anymore. B prime is at the left-hand side. So this is not just a reflection. I actually had to turn the shape. All right, now let's look back at our answer choices. If I had my answer choices, remember how I said this was not a reflection? Because the coordinates had moved places, right? Okay, now let's see if I went 90 degrees counterclockwise. On the computer, I certainly went opposite of what a clock would go. This is where A, B, C used to be, and I went this way, which is opposite of a clock. And I only went 1 turn. So my answer is C. All right, let's look at number 6. Number 6, I have a triangle PQR. It is dilated by a scale factor 2 to form PQR. Well, let's remember that a scale factor that is bigger than 1 is an enlargement. So that means PQR is smaller, and P prime, Q prime, R prime is bigger. Let's look at our answer choices. Each side length of PQR is twice the matching. So I'm going to put matching. because that's what corresponding means. It's twice the matching side length of triangle P prime, Q prime, R prime. Well, guys, that's just not true, because remember, this is an enlargement, so this has to be bigger. So I'm going to cross this out. The sum of the angles is twice the sum of the angles in triangle PQR. Well, that has to be wrong for two reasons. Number one, the original triangle has to be 180. And since this new shape is also a triangle, hey, that also has to be 180. I don't see that changing to where it's twice the sum. So I'm going to cross that out. Also, remember, when I dilate something, all the angles stay exactly the same. All right, let's look at letter C. Each side length of PQR is 1/2 the corresponding side length of triangle P prime, Q prime, R prime. Now that sounds much better because the original triangle gets doubled. So it would make sense that the old one is only 1/2. That sounds much better than answer A. I guess answer A was just backwards. So that's what makes letter C correct. All right, let's look at letter D just for fun. PQR is congruent. Well, hey, we know that is not true. The new triangle has to be bigger. So there's no way the old triangle is congruent. All right.